Alright guys, how's it going? Yesterday we started our review for the test, which is going to include some of the parametric topics from Chapter 8 and then some of the topics that we covered in Chapter 12. So at this point we've reviewed everything we need to review for parametric equations. Just make sure that you're ready to answer questions, either parametric equations in Cartesian or parametric equations in polar coordinates that involve things like finding tangent lines and slopes and concavity, be able to find areas and arc lengths. And we went over a lot of those problems yesterday. As far as Chapter 12, we've already covered some of the basic vector things. You should be able to find the dot product between two vectors, the cross product between two vectors, use either of those two laws to find the angle between two vectors. And what we have left to do is to talk about lines and planes. So I've put together some problems from your homework, so you guys can go back and look at your homework problems, and you can also follow along with me as we do them as a review for lines and planes as they appear on the test. So if we're looking at your book, we've just finished talking about vectors, like the cross product and the dot product, and we've done most of those things. The laws and theorems are important for you to know, but you will not be tested on memorizing them on the test. It's important that you know these theorems and that you have them written down somewhere where you can refer to them, because they're used heavily in later sections that we'll cover, but I'm not expecting you to memorize them, and I don't want to waste time on the test seeing if you have memorized them or not. So anyway, the next section is equations of lines and planes. You should be familiar with the different ways that you can express a line or a plane. On the test, I'll accept your answers in any of the forms, but you should be familiar with them because I am definitely going to be giving you information in different ways. Okay, so you should know the parametric form. You should know the symmetric form for the line. You should know how the vector equation is used to express line segments. As far as planes go, you should know the vector equation of a plane. You should know the scalar equation of a plane. And then this last one, the linear equation, is just basically this solved out and collecting all the terms into D. But you should know that as well. As far as general knowledge, you need to be very aware that the direction numbers for a line are easily gotten in any of these forms. You just need to know where to look. So the direction numbers, which show the basically slope, if you're thinking in 2 dimensions, of the line, can be found by looking at the coefficient in front of the parameter in the parametric equation, or by looking at the denominator in the symmetric equation. So you should be able to pick that out and use that where necessary if you're maybe needing to do a cross product to find a perpendicular direction or something like that. As far as the plane goes, you should know how to find the direction vector or the normal vector for the plane. Again, coefficients here, coefficients here. And again, you should know that the plane is defined with a normal vector because that normal vector is mutually perpendicular to 2 other lines that are contained in the plane. And so then the plane is fully realized in that way. And then we have the distance formula. So we have a distance formula between points in 3 dimensions that we covered long ago, and then we also have this distance formula for the distance between a point and a plane, or we could also use it for the point and a line. So you should be familiar with that as well. So right now, let's go ahead and do some problems. So we're going to start with question 5 on page 802, and we'll go through these questions together. All right, so question 5 says that we'd like to find the vector and parametric equations of a line that passes through the point 1, 0, 6 and is perpendicular to the plane x plus 3y plus z equals 5. It's important for us again to realize that we were given a plane, so the vector that's normal to the plane is given by the direction numbers 1, 3, and 1. So here I've written a vector that is my normal vector to the plane, and since they asked me to find a line that's normal to the plane, then I just need a line that's parallel to these direction numbers. So I've written out in vector form the equation for the line, which I've called A. It needs to pass through the point 1, 0, 6, so I'm going to have it pass or start at that point, 1, 0, 6. And the direction numbers of 1, 3, 1 show up next to the parameters, so 1, 3, and 1. I could also write this, right now this is in bracket notation, I could write it in unit vector notation by writing 1 plus t, the quantity I hat, plus 3t, j hat, plus 6 plus t, the quantity k hat. So that would be an acceptable answer as well as far as writing the vector form. They also asked for the parametric equation, so we can write that out. X is equal to 1 plus t, y is equal to 3t, and z is equal to 6 plus t. Okay, so any of those answers would be fine. Let's try another problem. So let's do problem 9. So here problem 9 says that we want to find the parametric equations and symmetric equations for a line that passes through two different points. So this is the direct analog of a problem you did in Algebra 1, except now we're doing it in 3 dimensions. So here are those 2 points, 0, 1 half, and 1. And the other point is 2, 1, negative 3. The first thing that we need to do in order to figure out the equation for this line is we need to figure out the direction numbers for the line. We need to find its slope, essentially. So we can do that by creating a vector that starts and ends between these 2 points, or at least points along a vector that goes through those 2 points. So the easiest way to do that would be to write a vector that starts at the origin and has this termination. So it terminates at 0, 1 half, negative 4. And that vector would point parallel to a vector that goes between those 2 points. And I got those numbers by finding the difference. 2 minus 0, 1 minus 1 half, negative 3 minus 1. So again, if we're looking at what's going on, I have a 3-dimensional coordinate system, and I have 2 points somewhere in space, point here and here, and a vector could be defined that goes through those 2 points and has some direction. All I really care about is the direction of the vector, so I can easily, in the way that I just showed you, find a vector that starts at the origin and points in a parallel direction. So that's what this is done here. Once I have that, all I need in order to be able to define this line is to pick a point, and since it needs to pass through both of these points, I can pick anything. So I've actually picked 2, 1, 3. So I've defined the line as being here and extending outward in this way. But if the parameter ends up being negative, the parameter t, I can complete the rest of the line. So it doesn't matter which of these 2 points you pick. I picked 2, 1, negative 3. So the equation in vector form for me is 2 plus 2t, so that 2 came from the direction, 1, which came from the point, plus t over 2, which again came from the direction number, and negative 3, which is my origination point, and the negative 4, which is my direction number. And that's my vector equation, and then I can also write my parametric equation. If I had picked point 1, the equation would have come out slightly different. Would have had 0 plus 2t, 1/2 plus t over 2, and 1 minus 4t. Both are acceptable. Alright, let's do another problem. Do problem 25. So we've done a couple with lines, so let's go ahead and do a plane. We want to find the equation of the plane. 25 says find the plane that passes through the point 1, negative 1, and has the normal vector 1, 1, negative 1, or ij, negative k, if we're talking about unit vectors. So in this case, the point is 1, negative 1, 1. Since they gave us a vector that's normal to the plane, and we know that planes are defined by a normal vector, we can go ahead and use this as our normal. So 1, 1, negative 1. And in writing out the equation for the plane, we just need to include our direction numbers, which are here. So here's one direction number, 1, the next one, and the next one. So 1, 1, negative 1. And we follow x minus the point, y minus the point, so y minus negative 1 is plus 1, and z minus the point. So this is the equation of the line, and that all we really needed to do was plug things into the form of the equation for that plane. Alright, let's try a problem that's a little bit more complicated. So we're going to do problem 35. So if we look at problem 35 here, go to the next page. 35 is right here, so we want to find again the equation of a plane. And the plane passes through a point and it contains a line that is defined here. So this is not quite as easy. If we imagine what's going on here, we're trying to define a plane. Let's say that this is our plane. We're trying to define a plane, and that plane should pass through a point and contain a line. And we know that the plane is defined by a normal vector that sticks up, normal to that surface. So what we could do is we could find a new line, another line, pick any point on the line that was given, and connect the point P1 that we were given to that random point on the line that was given. By doing that, we can do a cross product and find a vector that is mutually perpendicular to those two lines that lie in the plane. And in that way, define the plane. That's what we're about to do. So here's the point P1, and here's the line defined parametrically. To find another point on the line, we need to pick anything. So we pick t equals 0. So if t equals 0, then a point on this line is 4, 3, 7. So that gives us our second point, 4, 3, 7. In order to find a second line in the plane, we're going to find a line that is, or at least a line that is along that direction. We're going to use P1 and P2. So here you can see I've done 4 minus 6 is negative 2, 3 minus 0 is 3, 7 minus negative 2 is 9. And so that defines the direction of this second line here. Now that I have the direction of the second and the first line, if I do a cross product, I'll find the direction numbers for a line that's perpendicular to the two of them. And you can use your calculator for that. So if you're using a TI-89, we can use the matrix program, the matrix editor. And I've already entered these just to save time. So we have ijk, we have the direction numbers of